This is a problem understanding presentation for the ALLIS project for team number 11. So there are three questions that we typically ask when trying to understand a problem when it comes to design or building anything, and it's who is the customer, what do they need, and why do they need it. In this case, the customer is us as a team because we are going to be using our device. The ALLIS judges are also a customer because they'll be judging how well our device gets to the target location, and also Dr. Vaughn. What do they need? You need a device that will autonomously navigate to a target in the desert. And why they need it? We need it for the ALLIS competition. So this is one of our primary design tools we use, and it's called the House of Quality. Now this isn't the whole House of Quality, this is just the problem understanding form of the House of Quality, which some would argue is the most important part. On the left side, there are customer requirements that we have come up with, and on the top of it are engineering requirements. Now this isn't a full House of Quality, we cut it short for presentation's sake, but these are a few of the most important parts. So as you see in the first column on the left, it says fit, size, and weight requirements, and that is a requirement that is set forth by ALLIS as they're one of our customers, and so we have to meet that. And on the top you can see there are a couple engineering requirements that correlate with fit, size, and weight requirements, such as compact structure. Compact structure very strongly correlates with being able to fit a size and weight requirement, because the more compact it is, the smaller it will be, or the less compact it is, the bigger it will be, and maybe the more it will weigh. If you go down the column of compact structure, you can also see that it correlates with being cost effective, because the more compact it is, the more it will cost, or even the less it will cost. If you move over to battery life and go down, you can also see that battery life correlates with fitting, size, and weight requirements, because the bigger battery weighs more and is bigger. If you go down to travel to target and battery life, you can also see that it correlates together, because the longer the battery, the further we'll be able to travel. And battery life also strongly correlates with cost effectiveness, because a bigger battery will cost more. So that's just a couple of the ways that this problem understanding form helps us understand our problem. The next design tool is a function tree. And the function tree shows the main function broken into sub-functions that will break into more sub-functions to make this easier to understand. So the overall function of our device is to get to a target location. We've broken this into three sub-functions, which are survive, landing, and launch, autonomously navigate to a target, and travel to a target location. Now on a function tree, this would break down even further, but we weren't able to put it all on one slide, and so this just shows the basic working of a function tree. The last design tool is a spec sheet, which is a more helpful tool when getting real numbers for what your device has to do. On the left side is a column that says demand and wish, and that shows if it is a demand of what we want or is it a wish. The middle is the actual specification, and the right column is the source from where that specification comes from. The first two specifications are demands, and the first one is to fit in size of 5.75 inch diameter by 9.575 inch height cylinder, and that comes straight from ALLIS. That is a demand of the competition that our device must fit inside of. It also must have a mass lower than 1,050 grams, which also comes from ALLIS and is a demand of the competition as well. The next two specifications are to travel at speeds greater than 2 kilometers an hour and have battery life longer than or equal to 6 hours. Now those come from our team itself, and those are wishes that we would like our device to accomplish. It's brought to our attention that due to wind conditions, this device may have to travel up to 10 kilometers, so those two specifications will easily give us 10 kilometers. The final specification on this list is that it must stop within 100 meters of the target, and that is brought forth by ALLIS, and it is a demand because that is how the competition is judged. So this is a simple view of a specification sheet for our problem. This has been a problem understanding presentation for the ALLIS project. Thank you for listening. This has been for Team 11.